as last time, so I'll start and then you
Okay, perfect.
with the idea side, and then you can move on with the hello world
Okay, awesome.
for sure. So here we go. We can do this. Okay, just want to make sure everyone can see my screen.
Yep, that's good.
Perfect. Sounds good. So, hey everyone, really excited to chat about Uniswap v4 hooks and EigenLayer AVSs, and specifically the intersection between, because I think there's so much you can do. Quick introduction. I'm Ishan from Eigen Foundation. I do AVS strategy, so working with AVS teams and then also like helping design different mechanisms or like technical architectures. So if you decide to work on an AVS, really excited to work with you. And my counterpart is Nader. Do you want to briefly intro yourself?
Yeah, I'm Nader. I've been working in developer relations for EigenLayer since February, but I've been a developer for about 12 or 13 years, focused on developer education for about 7 years, and excited to be here.
Yeah. So I just want to start off by saying why I'm so bullish on Uniswap as a whole. And just a bit of brief history. I think that Uniswap V1 gave like it started this exchange for on-chain token swaps, right? Uniswap V2 was gave us more of these like ERC20 to ERC20 swaps, so you didn't need to route through ETH. It gave us flash loans, it gave us oracles as part of the AMMs, which are very cool. And then V3 built on top of this, it made it viable to actually build real exchanges with concentrated liquidity. Otherwise, you just needed it so much more liquidity in order to get to have any reasonable price. V4 is something else entirely. It's not an AMM, right? It's a platform so that you can build any AMM. And what I think this means is that you can recreate any on-chain exchange. So remove the club versus AMM debate. You can recreate any exchange with Uniswap v4. And so what I want to do right now is just try to reinvent CowSwap, which is a very notable large exchange. And I'll start off by explaining what CowSwap is, and then let's try to recreate CowSwap with Uniswap v4. So CowSwap is an AMM that it has a really interesting design. It's matching buy and sell orders for a token pair, so that these traders they can pay less fees and be matched directly with each other. And then whatever remaining fees there are, like remaining trades they can be settled on a pool. So how this works is imagine you have, let's say I'm trading, I want to buy like one ETH and I have 1,000 USDC. Now Nader wants to sell two ETH and he has like 2,000 USDC. Now you can he wants to receive 2,000 USDC. So what you can do is you can combine our orders. We can trade the one ETH for 1,000 USDC with each other. And now Nader's additional one ETH order can be settled onto the exchange. And what this means is that Nader and I don't have to pay the 0.3% fee or whatever fee it is. It's customizable with V4 hooks. We don't need to pay that fee on $2,000 worth of volume, and the fee effectively got reduced by a factor of a third. It also protects users from MEV, and it enables users to like they can just sign a transaction and then have this be move forward. We won't dive too deep into the solver auction and like the MEV protection just yet, but that's also fairly easy. But let's see if we can recreate this with Uniswap v4 hooks. So how do we do so? We can, let's say we wanted to just do it right now. We could send all of our, you can't really have these orders being stored on chain. But what you could do is send all of the orders to a single node operator. Now, this leads to some additional complexity, right? If this node operator is storing the orders and then matching them, it leads to centralization concerns. What happens if this node operator goes down? They might want to censor. So we want to send not just to a single node operator, but a network of node operators who can store these orders and match them, which is computationally expensive. So can they do this? Yeah, if you have a distributed network of node operators, they can match like the buy and sell orders for a token pair, and then they can send all of the remaining orders to this on-chain pool, which is the Uniswap v4 hook pool. And the question is, how do you get access to this like decentralized network of operators? Are you going to create a whole new blockchain that specializes in just this? Maybe, but that might be a bit difficult, and you also don't need a finite state machine. And you want to make sure that they're able to perform this like external computation that might be too expensive for blockchain. So this is where EigenLayer comes in. EigenLayer is an infra platform that gives you a decentralized network of node operators who are willing to run any arbitrary software that you have, and they're economically aligned to act honestly with your protocol. And we call these decentralized networks actively validated services, or AVSs. And what this means is that you can have a decentralized set of operators who are effectively doing whatever you want. In this case, they're receiving orders from different nodes, receiving orders from all traders, and then matching them using whatever algorithm they want. You could even have an auction for what gives the best matching, and whoever wins that auction can settle the trades on chain. So how does EigenLayer work as a whole? We have these AVSs, these networks, but they're run by individual operators. And how do you make sure that these operators are going to act honestly with your protocol? You need to make sure that they have stake. And so you can have restakers provide economic security to these operators. And they do this by restaking ETH. Effectively, you take staked ETH, it could be either natively staked or a liquid staking token, and then you can delegate that to operators. And so these operators have economic security that can be slashed if necessary, and they're also earning rewards if they're doing their job properly. So why would you use EigenLayer in the context of Uniswap? Maybe you want to batch many transactions together. You could run an auction. You can remember these operators can do any arbitrary information. It doesn't have to be on chain. So they can gain access to real world in real time information like prices, so maybe like an oracle, or like volatility, which is beyond the scope of what most oracles currently offer. If there's a stablecoin dpeg, you can plug that into your calculations, what the liquid staking yield is, and much, much more. So I want to take a step back and see if there are any questions, and then we'll dive into like a lot of the ideas that we have. So I see that we already have one question, which is a principal agent problem between restakers and node operators. You could think of this problem as the same that exists between any blockchain, right? In a blockchain, you can delegate your stake to operators, and these operators are the ones who are actively validating Ethereum or any Cosmos chain or Solana. What we do to make sure we mitigate this principal agent problem is we have the node operators One, you only delegate to people who you are each individual person is trusting. And then yeah, you only delegate to people you individually trust. And two is many node operators, they see this and they want to mitigate this so that you are actually using, so that you will delegate to them. So what they'll do is they'll self-delegate their own stake. Let me know if that didn't answer your question, Fahad. Question from Yi. How does AVS differ from an optimistic oracle like UMA? So why use EigenLayer? We actually love the guys at UMA. Why would you use EigenLayer? So you use EigenLayer if you want to do anything that's, sorry, okay, scroll down. There we go. So you use EigenLayer if you want to do any arbitrary computation. I think UMA is very good for identifying like for polymarket, in polymarket, it's able to identify sources of truth. But it's not necessary, the UMA operator set is not necessarily able to do a lot of more like computations, like storing orders or running an off-chain auction. If you have a price feed or selection between two options, something more basic, then I think UMA works well. Another difference I'd say is that where actually UMA does better than EigenLayer is that EigenLayer is limited to what is, you could say, inner subjective, which means that it's what is effectively objective in the real world. It has to be a black and white answer, whereas UMA allows for degrees of subjectivity, and it's effectively it's like a UMA voting choice. And a good example of this is asking, was the Ethereum ETF approved? It was approved, but not necessarily tradable. So there was some disagreement. It wasn't a black and white question. You can't use EigenLayer for that because it has to be black and white. These node operators are running specific computations. But in UMA, they're actually voting. Not too, yeah, let me know if that answered your question, Yi. From Thomas, how does CowSwap match orders without something like EigenLayer? Is it that CowSwap is centralized and we are going to build a decentralized version? So CowSwap uses a solver network, and what that means is that they're effectively running an auction. The process of running the auction is centralized, but the people who are actually the people who are actually choosing their the people who are actually executing the transactions are like many independent solvers. From Miran, how does a hook deployed on mainnet interact with an AVS I create or an existing one like Athena's? So you can call out you can reach out to AVSs both on-chain and off-chain. Remember that the AVS contains any arbitrary software, and so you can create like connections on-chain. As part of the process of deploying an AVS, you'll deploy a very small contract called an AVS registry contract. And what this does is that it connects your AVS with the on-chain world. Nader might be able to talk more about that during the code process. How does EigenLayer relate to ERC 4337? Ayal, can you elaborate on 4337? I'm not too familiar with that one. Is the on-chain oracle an alternative to a Chainlink price feed? Yes, you can use an AVS as an oracle if you want, or you could use like an AVS oracle. We currently have eOracle that's live, and then a few others that are planning on becoming becoming AVSs. And what this is super cool because now you effectively have a verifiable oracle. Whereas like if Chainlink gives the wrong price feed, there is no punishment. There's no real economic security behind that. But with an AVS oracle, you can have that. How much can arbitrary data computed by EigenLayer be trusted? So for Pedro, this is you trust it the same way you would trust a blockchain, right? The goal is not to trust the operators because they say so. The goal is to rely on no trust and say that, okay, if the economic security behind a certain AVS is, let's say, 1 billion, then I can trust the data computed by this AVS as long as the profit from said corruption, if that data was incorrect, is less than or equal to 1 bill. And so each AVS will have their own individual amount of economic security that is given by the EigenLayer network. But in general, we're seeing that it's quite a lot because EigenLayer as a whole has $15 billion in TVL. So for all intensive purposes, you can trust the data as long as the AVS has enough economic security. Is AVS primarily for orders? What is an example for AVS use case with more arbitrary computations? Ben will talk about 6 more ideas. So I'm very excited for those. Leandro, distribution of the key stores between so for the distribution of the key stores between the different validator nodes, what system do you use? I'm not sure I understand your question, Leandro, but all of the operators maintain their own private keys, and maintain their own private keys, and they're effectively running their own computation. Feel free to elaborate. What does strategy manager.sol enable to do? For example, building a lending protocol, how would deposits from lenders be incentivized using AVS? I'm not sure I understand your question, Mehdi. Sorry. Can you elaborate more on that? From Pablo, how do you contest data if you think it's wrong? What you can do is you can have call the slashing function on the AVS for that operator. And what will happen is that if your proof is correct for that slash, then the AVS will slash the operator, and then depending on the implementation on the AVS's side, you can actually redistribute those funds to the parties who were harmed. We let the AVS handle that. EigenLayer does not handle that. Right now, slashing is not yet live, but it will be by end of Q3, beginning of Q4. Should the computation be deterministic for EigenLayer? Yes. Pratik. 33 audits. It's not clear to me how challenges work for operator. If I say ETH is worth 5,000 and someone challenges that, who verifies that the challenge is true and my answer was false? So 33 audits. For price feeds, we actually have something that's more a bit more complicated. So I don't want to dive too deep into it, but happy to chat more after. Where we use something that's not called objective slashing, which relies on proofs on chain, but something called intersubjective. So slashing. So objective slashing, it relies on proofs on chain. It's for what is provable on Ethereum mainnet. Intersubjective is for what is objectively true. There is a right and wrong answer, but you can't necessarily prove the price of ETH on chain. And so you rely on the eigen set. You rely on the set of eigen operators who are effectively performing calculations off chain to verify whether like if someone is being slashed, whether they should actually be slashed or not. I can send more information about intersubjective later. ERC 4337 proposes creating a subnetwork of the ETH network, creating an alternative mempool through which some transactions could be sent and mainnet transactions be bundled. Oh, that's actually really cool. So would EigenLayer also be an alternative mempool network? I would say no. An individual AVS can be an individual AVS can uh, include an alternative mempool network that does some extra computations. In this case, this would be like you could, yeah, in this case with CowSwap, you could think of the AVS as an alternative mempool network. And you could even make it private if you want to, using other encryption technologies. Like I know Shutter has some cool privacy things, or you could run everything in a TEE as well. Mehdi, let's talk about strategy manager.sol offline. Okay, I think those were all of the questions, but if there's anything else, happy to chat. If not, I'll dive deeper into ideas. Okay, thanks for that. That was a lot of really cool questions. So we have 6 ideas. The first is solving coincidence of wants, and this is just what I was talking about beforehand, right? We have taker flow that can exist in both directions, like buy and sell for any given pool. AVS operators can match these orders together and reduce the overall flow that gets sent to the Uniswap pool, thereby reducing fees for the takers. And if you have lower fees, then what that leads to is more volume in the long run. A second idea is having dynamic fees for periods of high volatility. And so we know that LPs, they do better when prices are stable, but there is volume in both directions. So what we can do is determine when is there high volatility and then adjust the fees to compensate. The hook side can adjust the fees, but how do you determine what is high volatility? And in order to do this, you can do uh, what you can do is like run some calculations off chain to determine what like have a uh, have a formula for what volatility looks like, continuously calculate it, or calculate it maybe like every 12 seconds or every 60 seconds, and then whenever it's higher, then you can adjust the fees to compensate. So now, what about when you have LST pools? So think like staked ETH, or like RETH USDC, right? What we have when we have in any traditional Uniswap pool, you have a fixed X times Y equals K formula, and the ratios are constant. But what in any staking token, you're effectively having the natural price, it's drifting upwards. So in staked ETH, we're seeing that in staked ETH, you're seeing that the prices of stETH are increasing and the price of ETH stays constant. So in a traditional pool, what you're going to have is that the LPs are going to be continuously arbed against. But you'd rather just change the curve or change the composition between the two assets within the pool itself. And you can do that by determining what does the yield rate look like, reading that, and it doesn't have to read very often. And then whenever you can move all of your LP positions up the curve by a constant amount to compensate for this new price. So let's say Steth has a 3% APR. Every day or every week, you could move by that proportional amount. This idea is a bit more complicated, but something I'm super excited about. And it deals with this idea of dark pools. So some people are willing to wait for their transaction to be executed, but they want really optimal prices. Maybe they have a large amount of tokens they want to sell and they don't want anyone to know about their orders. They don't want to post it on the order book, or like post it directly on chain. And so you can have AVS operators hold orders privately, and then they can match market orders together at the price of the most liquid exchange. So you can say, we're always going to give you the Binance price for, let's say, ETH USDC. And but the way we're going to do that is you're going to give us your ETH, and other people are going to give us their USDC. And we're going to give market orders, like transmit market orders between each other. And again, everything is private, so no one on chain actually knows that you've deposited your ETH and USDC here. This idea is probably the one I'm most excited about, but the most complicated, because you need to run an off-chain auction. And it deals with something called loss versus rebalancing, or lever. So what lever is that it's an arbitrage that causes LPs harm. And so there's a price discrepancy between continuous off-chain exchanges like Binance and on-chain exchanges like Uniswap, which are trading every block or every 12 seconds for Ethereum mainnet. And so let's say the price of ETH is 1,000. So at ETH USDC, it's $1,000. And then 12 seconds later, the price of Binance has shifted to 1,050, but the price of ETH on mainnet stays at 1,000. Now, the first transaction on the pool, what they're going to do is it's going to be a highly sophisticated actor that's paying validators some fees to be first. They're going to try to arb the entire pool. And this isn't really good for the LPs. Ideally, you'd have those fees that are going to validators go to the LPs themselves. So what you can do is you can have the run an internal auction and predetermine who's going to be the first transaction that touches that pool. You can determine this with the smart contracts, or with the smart contracts by determining that like X will always be the first, and you can have them route that trade to the pool and be the first one to touch it. And then the proceeds of this auction go to the LPs, thereby mitigating any harm that comes from lever. And assuming you have a highly competitive auction, then 99% of the like arbitrage that they would lost would go back to LPs. And last idea is we have this idea of a shared state across all chains. And this is where, let's say you have AMMs that can have different prices across chains, right? Uniswap is on Ethereum mainnet, a bunch of L2s, Polygon, Celo, and many more. So right now, the prices are different for every like every blockchain exists as its own siloed system, and the reason for that is that we have no way of transmitting shared state. So one thing we could do is have operators maintain like an aggregate knowledge of like what is the total pool on sorry, what is the total amount of capital and what is the current like best price? Uh, and then but run execution on every chain locally. So when traders are sending orders, they're going to trade against this combined pool and receive less slippage than if they had traded on the overall on like an individual pool. It doesn't make a huge difference if you're trading on Ethereum mainnet, but now if Uniswap wants to deploy onto another chain, now you have the liquidity of all of the chains combined on this new chain, which means that for every new chain you add, it's going to be super fast and the network effects immediately kick in. So happy to dive into any other questions. And I also wanted to talk a bit about like just share some other resources. One is their Atrium Academy's request for hooks page. We have all of them over here on this like EigenLayer v4 hook ideas as AVS. Alternatively, we wrote a blog post, we co-wrote it with the Uniswap Foundation that effectively goes through this whole presentation and dives deeper. If you have any questions, feel free to reach out in the any questions after. Happy to chat more in the Discord, but for now I'll answer questions in chat. So with dark pool, is there any centralization? That really depends on your implementation. You can have a single operator with high and like with high economic security. The ideal implementation uses some level of ZK. I'm less familiar with the ZK side, but there are a few AMM teams that have built are like trying to build this out separately, like Renegade. I think it'd be a lot more efficient now that Uniswap v4 is existing, like about to go live, if they built as v4 hooks instead. The MEV rewards to LPs redistribution idea already implemented. I think some people built this as part of the last incubator, but really I think it's still a very viable idea to pick up. I think all of these, it's all about execution. So I wouldn't worry about what people have done in the past. Instead, think, do you think you can build this better than anyone else? And I think as long as you think really deeply about these problems, and talk to traders and LPs, then you can build out a really successful hook. Thank you, Harsh, for linking. Any other questions? Unfortunately, no token talk. Okay. If not, I really want to dive deeper into the actual process of building out an AVS. So happy to kick it off or like hand it off to Nader. Okay, sorry, I see two more questions. How off-chain computation is secured by EigenLayer? So the way this is done is that you have you you could think of it almost like a rollup, right? In a rollup, you have these off-chain nodes that are running computation. Usually, it's combining transactions or like executing transactions in an EVM environment. And if one is run incorrectly, then you can you try to submit it to Ethereum mainnet as like you batch the transactions together, and then you can slash if necessary, or like you can challenge the transaction if necessary, and if so, none of the transactions go through. EigenLayer has a different model where we're relying on economic security rather than saying everything goes through or does not go through. And what this means is that operators are running computation on their own machines. And then the AVS can choose to either aggregate the computation or aggregate the computation by like selecting from multiple and deciding like, let's say we need 5 people to agree or 51% of the network to agree. But the whole purpose of an AVS is to say that it's much more flexible of how the computation is calculated and how you as an AVS are determining that the computation is secure. The one thing that cannot be changed, it's not an it's not an optimistic rollup, but it does use optimistic methods. The one thing that cannot be changed is that if you have if you have computation then that the operators are running, then they should be able to be slashed if they run the if they are malicious and misreport an incorrect computation. And so the way to best do this, the best way to do this is make sure that whatever code you're running is that the operators are running is open source, so that other people can verify it themselves, and then they can slash as needed. And then you have this economic security in the form of ETH. And this enables, you have this economic security in the form of ETH. What this does is that it operates the same as any other blockchain because every blockchain relies on economic security in order to, effectively anti-Sybil and economically align the operators. And then you can, but by using ETH, you're effectively reducing the need for new stake to be created. With regard for aggregating liquidity across pools in different chains, would it be correct to say that it is facilitating arbitrage between several pools, or does it go beyond that? Ayal, this depends again on your implementation. I think the best way is to not arbitrage across pools, but instead maintain a shared information layer and then unique execution layers on different chains. And so let's say you have, I'll just use V2, X times Y equals K instead of concentrated liquidity for example explaining purposes. But what you can do is you can have, let's say you have $1 million of liquidity on Ethereum mainnet and $500,000 of liquidity on Arbitrum. You could say, okay, we're going to have $1.5 million in total liquidity. And then any trade is calculated using the X times Y equals K formula for that specific amount of, for that amount of liquidity. So you have less slippage. And then the trade still executes on the individual liquidity. If needed, you can bridge liquidity from one chain to another, but ideally that's not necessary. Can we build a bridge with AVS? Absolutely. We have a few teams building that, but highly recommend. Right now, Hyperlane is live and Omni is launching soon. On automatically adjusting LP positions for LST pools, how can this be done? So the hook would be changing the, so again, depends on implementation, but one implementation is the hook could could adjust the LP positions, the concentrated liquidity bounds, and let's say increase the minimum. Let's say my let's say I have deposited liquidity at like 1 stETH equals 1.1 ETH to 1.2 ETH. You could increase that to 1.2 ETH to 1.3 ETH. Rough numbers, but you could use the hooks to do so. So with AVS, we don't need to use ZK proofs coprocessors. You can actually build out a zero knowledge coprocessor with an AVS, or you could rely on, so we have teams like Brevis and Lagrange who are doing that. And the reason they use this economic security in addition to the zero knowledge proofs is so that you only need to use zero knowledge proofs when someone you only need to use the zero knowledge proofs on an optimistic basis, and then you have this economic security that determines which operators are actually running the computation, so that you have a base level of security and then can use zero knowledge proofs as needed. AVSs are kind of chain agnostic. They exist as their own separate set of operators that can interact with any chain. The AVS registry contract is deployed onto Ethereum mainnet, so that serves as a default gateway, but you can effectively deploy this or bridge it anywhere. And we're building a system internally that enables your AVS to be truly chain agnostic. Okay, I think I answered Matthew's question as well. Perfect. So I know we're running short on time, so I'll hand it off to Nader to talk more about the actual building out an AVS side.
All right. I will go ahead and share my screen here. All right. Can everyone see that okay? Great. Okay, cool. So I have like a presentation, but it's very, very short, and I feel like we don't really have a ton of time, so I might not even go through that. But I will just kind of like maybe highlight this idea that you have developer platforms that we've seen throughout the years that have really kind of changed the way that we think about building things. So a good example of a developer platform that most of us are very used to is probably the App Store. You know, before the App Store existed, it was a lot harder to ship an app and get a lot of, you know, distribution, right? It also provided frameworks and tools and everything you would need to kind of build and deploy an app with trade-offs, you know, limitations a little bit there. You also have these developer platforms like AWS and GCP for building web services, and that changed the way that we built applications. And in terms of like the blockchain space, before Ethereum was around, before the first smart contract platform was around, you had to actually build blockchain functionality into the network itself. You couldn't create a program and deploy it and share security from the underlying network. So Ethereum is essentially shared security for dApp development or smart contract blockchains, or that, because before you had Bitcoin, you had Litecoin, you had Mastercoin, you had all these different versions of distributed ledger platforms. But you couldn't actually just write some code and share that economic security. So the easiest way to explain EigenLayer, in my opinion, is that we're taking this same idea, the same principle that we're used to, but we're expanding it outside of the VM or the EVM, if you consider Ethereum, but outside of the VM completely. So you can build anything. You can build any arbitrary decentralized network, any proof of stake network. And Ashan touched on some of the stuff that you can build. These are some verticals that I might highlight. You have roll-up services, you have coprocessors, you have this other category where you have MEV oracles, decentralized storage, data archival. There's all types of stuff that you can build. And you can kind of consider any product that exists today that's successful, that was rolled from scratch, as a potential disrupting product that you could build as an AVS. And finally, if you want to kind of see some of the stuff that's already been built, you could check out the EigenLayer.xyz website ecosystem page. You could also check out the actual EigenLayer dashboard to see the live and the also testnet AVSs to get kind of some alpha there. But if you want to build, we're going to be focused mainly on this Hello World AVS. And this is, in my opinion, and by far the easiest way to just build the mental model of like how this all works. Because if you kind of start diving into our documentation and you start looking at the EigenLayer contracts, it's very confusing because there's just so much going on. But when you really boil it down, you're not really having to worry about dealing with a lot of that. You're just leveraging that to actually deploy and build. And as you're about to see this Hello World AVS, we're only going to really look at like 4 files. Everything else, we're just kind of leveraging to build this thing. And this is a very simple AVS, and it's probably not the most real world thing, but you can kind of take this and extend it to be more real world. We're just creating a message. We're verifying what that message says on chain through a set of operators, basically. But this verification is a principle that you can then, again, kind of extend to do a lot more. And this product right now, this Hello World, is built using, and it's available to be built using 2 different languages today, TypeScript and Rust. We're also adding Go because our SDK is in Go. But we have more complicated, or I would say advanced examples for the Go SDK. Incredible squaring might be another AVS I would check out beyond this. But what we want to do is we want to run this and just kind of like look at some of the code. So there are 2 different ways that you can run this. You can kind of just run these make files, which just deploy everything under the hood. But I don't really like that route because it abstracts a little bit too much away. So what we're going to do is we're going to do this manual deployment where we're literally going to clone this repo. We're going to start Foundry, or we're going to start Anvil. We're going to use Foundry. We're going to start our own local network. We're going to deploy the EigenLayer contracts locally. We're going to deploy our AVS contracts locally. We're going to start the operator software, and then we're going to start sending messages to be verified. So we're kind of like taking all 4 of these main steps that you need to build an AVS, and we're going to do those. So those 4 steps would be deploying your EigenLayer contracts locally, because if you were building on Holsky or mainnet, you wouldn't really need this. You could just obviously deploy to that network, but it's kind of nice to be able to just run locally. We're going to then deploy our contracts to that network. We're going to then run our operator software, and then we're going to run an additional script that sends additional tasks, which in this case are just messages. So I'm here, and I have these 4 windows open. And I'm in this Hello World AVS. And I'm running the TypeScript version of this. Okay, so the entry point for this operator, which is kind of like what we're going to be running, is really down here at the bottom. So we have this main function, and we're going to dive into that. But before we do that, let's actually go ahead and deploy this. So what I've done before I started the call was I cloned this, I copied the env files, and I went ahead and changed into the contracts and ran forge build just so we wouldn't have to worry about that. So our contracts have been compiled, and we can now start Anvil, which is a local network, kind of like Hard Hat. So we have our Anvil network running, we have our accounts, and now we want to deploy the EigenLayer contracts. So I'm going to change into my lib folder here. And we're in lib/EigenLayer middleware, which is something you can install just to have the EigenLayer contracts locally. And I have the EigenLayer contracts here. So what I want to do is just deploy those contracts locally. So I have this little script here that's just going to run this deploy script, and it's using one of these private keys that we have locally, and it's using this local host RPC. So nothing really too crazy there. The only thing, that you might want to look at would be the this JSON file, which is some basic configuration that we're kind of using to be able to deploy this. So I'm just going to run that. This might take a second. This should only take maybe a few more seconds. Maybe I should have gone ahead and compiled this as well. While that's compiling, I might go ahead and run and grab this next step. So we're going to go ahead into a separate directory, just change into the contracts directory here. And this is going to be where we deploy our AVS. Go ahead and get that script. All right, there we go. So we've deployed the EigenLayer contracts to our local network here. See all the transactions went through. And next we're going to deploy our Hello World AVS, which I'll walk through the code in just a moment. But before we do that, let's just deploy it so we can test it out. All right, so we've compiled and deployed EigenLayer. We've compiled and deployed our AVS contracts. So what we can now do is start interacting with it by running our operator. So the operator, like I mentioned here, is this TypeScript file. And really the main functionality is right here. We have this main function where we're going to call register operator. This is going to register our operator. And then we're going to listen for new tasks. And then once this listener is set up, we're going to be basically listening for these on-chain events. And once those on-chain events are essentially, happening, we're going to then respond to those. So let's go ahead and take a look at register operator here. Zoom out a little bit. So we have everything that we need to register as an operator for this AVS here. And this right here, I would say, is kind of the main method that we're interacting with on the registry contract. We're calling register operator with signature. And this is all essentially basically just, I would say, boilerplate. The real functionality that we're going to be diving into more is specific to our AVS. So once we register, we're going to be monitoring new tasks. So let's go ahead and call this, because what we're going to be now doing is interacting with the actual EigenLayer AVS contracts for our specific AVS. So just to test out that our contract is working, we're going to call create new task. And if we go to our Hello World Service Manager, this is our specific AVS contract. And if you see, we have a total of about 122 lines of code. And I'm going to actually paste this repo into our chat if anyone wants to follow along. But we're inheriting a few of the EigenLayer contracts and libraries and interfaces and stuff that we need. And the only two functions, or the only two pieces of functionality that we have going on, are these two right here. We have create new task and we have respond to task. So if we go back to index into our monitor new tasks, we see that we're calling create new tasks. So this is kind of the first time we're actually interacting with our own custom AVS. So what happens when we call create new task? It's pretty simple. When we create a new task, we're going to be passing in a string of eigenworld. This is going to be expecting that string here. We go ahead and set of a new variable called task name. We give the name as the name that comes in as an argument. We set the block number as the task created block value. We then update this hash with that with an incremental value that we then increment right here, which is essentially like starting at 0 and going up. And then we emit this new task created event. And when this new task created event gets emitted, we have another listener right here where we're creating the task, then we're going to be listening for that new task created event. So once this happens, we then have this next step that is called sign and respond to task. Sign and respond to task is going to take in the task name, and we're going to take the this message, we're going to sign it, and we're going to pass it back to our to the contract we just looked at. So we have create new task, and then we're going to be calling respond to task, and that's what's happening right here. And we're passing in the name and the block, and then the signature. And the signature is based on the message. So when we call respond to task, we're going to do a couple of checks. We're going to then update a data structure that we have here with all of the different tasks that have come through. And then as long as all of this verification is done, then it is, I guess you could say, assume that the task was completed successfully and all of our EigenLayer base verification has been done. It's pretty basic verification. We're making sure that we haven't already used the same index. We're making sure that the operator hasn't already responded, things like that. And once everything is done, at this point, the task is successful, and we update the local data structure with that new value, and then we emit a new message called task responded. And we don't really use that, I don't think, in our operator code. But if you wanted to, you could then create an additional event listener in your front end code or in your whatever code. So what we're going to do is going to go ahead and run this. So I'm going to go down here. I think it's actually, let me go ahead. All right, so we've now registered our operator. We see that after about like 2 or 3 seconds, we see hello eigenworld, and then we see we're signing and responding to task 0. So when we ran this main function, we registered the operator, we had the operator registered on EigenLayer successfully, and our ABS operators registered successfully. And then we call monitor new task. And again, that created this new task called eigenworld. We see that we responded here, hello eigenworld. And then now we're basically all just set up. And what we need to do now is just start spamming our operator with work to do. So the work that we wanted to do is just to start listening and creating a bunch of new tasks. We have about 5 minutes left, but so I'm not going to dive too much into this code, but basically all this is doing is taking this right here and just doing it every like 15 seconds or something. It's calling contract.create new task, passing in a random value. So if we wait about 15 seconds, we'll see a new task came in, and then we see hello with like some random value. And here we're saying hello lazy dog. We wait another like 10 or 15 seconds. We see hello quick mouse. So our operator is working. We have an application that's interacting with our operator. The verification is happening successfully. We have all of the very basic parts of an AVS working. You're going to want to add your own custom functionality. The place that you're going to be doing this on the contract side is going to be in this Hello World Service Manager. This is going to be where you can do the tasks, define your own custom task functionality. And the main two things that you're going to really need to worry about at first are going to be creating and responding. So think about that as kind of the main entry point. And then if you end up needing to do anything that's this function starts getting too large, or you start needing additional functionality, and you might even need to install additional dependencies and use other stuff. Your app is going to start getting much bigger, obviously, but the basic core things are going to be creating and responding. You're also potentially needing to update your deployer. Now, this script is fairly versatile in the sense of like you're not going to need to change all that much probably. You can essentially assume this is a very generic deploy script for a local AVS running it locally. And then we also have a Holsky deployment. But this is a fairly complicated and I would say more verbose like code base than what we just looked at. But for the most part, you're not really going to have to worry about changing all that much. I would say you might need to change 5, 10, 15% of this for a custom AVS. But for the most part, you can kind of use this as a good boilerplate starting point. So what we've looked at so far have only been three files: the operator entry point, the custom smart contract, and then the creating new tasks, which we really didn't even look at, but it's a very similar piece of code as we looked at earlier. And then if you want to get more complex and you want to start building out a custom deployment, then you might need to look at this hello world deployer.sol. If you have like additional technical questions, we have a dedicated like help channel that I shared the link to that we can bring in other people outside of me and Ashan, because like me and Ashan are probably not the most technical people on the whole team. So we have AVS engineers, and we're bringing in even more like I would call solutions engineers, solutions architects that can help bring in more, hopefully higher end support or more technical support. So if you want to get that type of support, definitely consider joining that discussion there. And one other resource I'll call out is this AVS book. And if you go to our, if you just go to the EigenLayer docs and you go to resources here and you go to learning resources, we have this whole developer resources section. So you'll see awesome AVS, and we don't have the AVS book there. Well, we don't have the book there. The AVS book will be linked in a few minutes. I'm going to add it right away. But yeah, the AVS book and then this resources is probably the two best places to go as a developer. Yeah, and that's about it. Yes, let me drop a link to the book. Okay, yeah, and that link that. So when would an AVS require an Oracle? Well, I guess if the verification that you needed to be done relied on Oracle.
So you usually use an Oracle to like get any data from an external source, right? And the AVS could definitely do this internally, like the operators can do it themselves. But if you want, you could also use an Oracle to outsource that.
Yeah, I mean, a lot of the verification is done, off chain by the operator and then verified on chain. So So it's essentially, if you have like 10 operators, as long as like, your quorum of 9 or whatever all come to agreement and they're all running, they can interact with external data sources that could be thought of as maybe as like Oracle type functionality, right? Ashan, you would say?
Yeah, absolutely.
Can AVS validators in theory post transactions? Yes, absolutely. The operators can do all types of stuff on chain if that's a requirement of them. So in fact, I think that's, if you look at a lot of the architectures that are and the coprocessors that we're seeing, a lot of that is like async programming, and a lot of the a lot of what's happening is them posting transactions to different networks. And it's worth also calling out that there is literally no requirement to build on Ethereum. In fact, we're seeing a lot more of the interactions happening on other networks like Base, even Solana. I mean, it literally doesn't matter. It's just that EigenLayer is bringing that economic security from Ethereum, but there's no limitations around where you can actually build services.
Awesome. I think we have one more question and we'll close. By Pran, what is the recommended way to pay fees in AVS?
Sean, do you know the answer to that?
I think this would depend on yeah, this would probably depend on the context of your AVS and like the implementation, but two ways come to mind. One is that it can be done within let's just use the cow swap as an example, right? If you want to transfer funds, if you want if you want uh, if you want the traders, the takers, to send their trades to the AVS, one really easy way of doing that is rather than having someone like them actually pay gas fees or pay fees to the AVS, is to just have them sign a transaction and not pay any fees altogether. And then the AVS operator, whoever is sending the fees to, or yeah, sending the aggregated trades on chain, can just take a spread of the trade rather than having anyone pay gas fees. And so then it's all handled externally, or like the operator can transfer on their own. So they can maintain some ETH balance, and then um, hold some, like if you're paying USDC, then the traders are actually paying USDC with like they're just paying USDC, which is their original quote token. And what's really cool about this is that now I, as a user, don't need to hold ETH or let's say SOL on any chain that I'm posting on. So, sorry, just to wrap that all up, lots of different ways. One way is having having the traders pay the AVS directly. Probably the best way in the context of DEX is having the operators take some form of fee, or some form of spread, so that the people don't need to spend any fees at all. In terms of the EigenLayer's business model, right now we're less focused on the revenue portion from AVSs, and we more so want to just grow out the economy. I think it's very cool to build out this like this market of permissionless innovation.
Yeah, we still have to ship a few more major important parts of the protocol, and then like once the platform is essentially, you know, where I feel like all of the main requirements are, I think we'll start thinking about that. But yeah, like the number one 100% focus really is just getting the AVSs that are building, helping them become successful, and getting the developer experience smooth to where people are able to build pretty easily. I think the ultimate goal is, okay, it's so easy to build a smart contract, right? But what if you want to build anything that is just an arbitrary proof of stake network? How can we make it that easy? So one of the focuses is essentially how can we, you know, make that happen, make building any decentralized network as easy as it is to build a smart contract. So we have a lot of stuff that's being worked on to kind of get us there. But for now, we're just focused on a handful of SDKs, reference architectures, and there's teams like Authentic that are pretty cool that help developers build and handle some of the more complex parts.
Awesome. So I want to thank Ishan and Nada for coming and taking this workshop. We got to see how you can integrate ABSs with Uniswap V4, and we also got to see hands-on building a Hello ABS project by Nada. It was really awesome to see, and thank you guys for asking questions, and thank you guys, Ishan and Nada, for answering the questions. It was really informational. If you guys have more questions about this, please do post in Discord EigenLayer channel. These guys will be able to help you there. And yeah, thank you guys. Thank you everybody for joining.
Thank you for having us. Thanks everybody for their time today.
Thanks, everyone.